discuss in this. First of all, 5G building blocks for private networks. So there are many new concepts introduced in 5G, like many use cases like EMBB, URLLC, MMTC. Then we have various 5G performance requirements related to latency, data, and various other cases, right? And then we have flexible frame structure, right? In case of 5G, we have subcarrier spacing of 15, 30, 60, and so on. And then we have this 5G spectrum as well, as we know that millimeter waves are introduced in 5G. And then we have this technology components, then we have this NSA mode, SA mode. So all these components or all these technology concepts, understanding is required if I want to learn private net. Then the second agenda will be the mastering the basic of private networks. So in this, we'll talk about how to define private 5G networks. These are also known as non-public networks. Then we will illustrate some examples, use cases of private networks and identify their requirements. In addition to that, in the third part, we'll discuss about private network architectures. And here we'll sketch the architecture and deployment options for the private 5G networks and set through private network operations. And also we'll see the key enablers of private network. After that, we'll talk about how to define the link budget for private networks, how to do the throughput and capacity planning, and complete RF design process from start to end. And in the end, we'll talk about model tuning as well as KPIs optimization as well. Again, friends, this is me. My name is Gaurav Goyal. First of all, thanks a lot for joining this training. So instead of spending time on Netflix, YouTube, Instagram, you are here. This proves you are serious about yourself. This shows career growth means a lot to you. So I will try my best to make every second of your work through this training in next 2 hours or so. So again, this is me. My name is Gaurav Goyal. So I have been in telecom industry for over 18 years. And I have worked for all the telecom providers in US like AT&T, Verizon, T-Mobile, Sprint, Dish, etc. And also with major vendors like Ericsson, Huawei, etc. And also with a French company called InfoVista, which has Planet RF design tool. And before coming to US, I have done various projects for various countries like India, Nigeria, Finland, Japan, UK, etc. So much of time has been spent in wireless network only. And I have begun my career with 2G and now working with 5G for last 5 years. So at this moment, my focus is on 5G, AI, ML, and Python and in-building solutions. And you can see I have done all the certification in in-building related to Solid, CommScope, Corning, JMA, and also done IB-Wave and private network certification. And for more details about me, you can go to LinkedIn profile, and I have already given my link to in the chat box as well. Okay, friends, this is all about me, and these are my access card, which are my biggest assets, because as told by Albert Einstein, the only source of knowledge is experience. Means that true understanding doesn't just come from reading, hearing, or thinking about something. You have to actually do it. For example, even if you read 1,000 books about swimming, you can't learn swimming without getting into the water. You won't fully understand how it feels or works. So you have to get some experience as well, in addition to reading, hearing, or thinking, right? And like in every webinar, let's quickly go through a few codes which I saw this week and which I want to share with you. So I have always wondered why some people manage to break their limits and grow while others stay in their comfort zone, right? The simple answer is this fear zone. So fear is the main thing holding us back. So how do we get rid of it? First, we need to understand terms like comfort zone, fear zone, learning zone, and the growth zone. So comfort zone, first thing is the comfort zone. So this is the mental state where we feel safe, we feel secure, we feel in control. It's a familiar, require little effort and feel easy. It's a low risk zone. So here we'll feel safe, but we are not really growing. And then comes this fear zone. So fear stops us from leaving the comfort zone. It lowers our confidence. It makes us doubt ourselves. Instead of creating the solutions, we create the problem. So we are more focused on the problem as compared to solutions. And then comes the learning zone. So if we pass this fear zone, then we enter the learning zone. So here we face new challenges. We look for new opportunities. We gain new skills and discover more about ourselves. It's about real growth begins in the learning zone. And the last comes is the growth zone. So once we pass the learning zone, we enter the growth zone, and this should be our ultimate goal in life. In the growth zone, we welcome challenges and step into discomfort. We push our limits to learn more, grow faster, and reach higher level of success. We have a motivation. We have high self-esteem in the growth zone. People have set big goals and work hard to achieve them with the help of this growth zone. It's not easy at first, but the rewards are worth it. That's why we should always aim to move towards the growth zone. To get there, we must keep learning, face our fear, and take action, even when it feels uncomfortable. For example, it's 6 a.m. right now in US, and I woke up at 4 a.m. today to prepare for this training because I choose to live in a growth zone, even when it is uncomfortable, right? So always try to live in a growth zone if you want growth in your life. So most of the people who are not successful have a fixed mindset. They think they know the best. They know this is good enough. They know, and after small try, they are not successful, then they give up. They think that I will be never that smart. For example, if a child who is still born, who is just born, if you say that he can't walk because he is falling many times, he never walk. A child who's never speak, he will say that no, I have not spoken for last 2 years. Now I will not be able to speak. He will never speak. So we should have a flexible mindset. And people who work make mistakes, right? So people who do not work never make any mistakes. So don't be afraid of making mistakes, but we should always try to move towards the growth zone. So in the growth zone, we always think that mistakes help me learn. But only thing with mistakes is that try to avoid the same mistakes again, right? And practice makes a man perfect. We know it, right? And feedback is valuable. Sometimes we think that somebody is not praising our work. It means he is not our friend. It's not like that. Always take the feedback, right? The feedback may be good or bad. Try to learn from that feedback and avoid to make that mistakes again and again, right? And try to improve your work by 5%, 10% every time. Don't run after the excellence. If you run after the excellence, then you will never achieve success. Try to get improve 1% every day. And after maybe 1 year, 2 years, you may reach the excellent. But at the first, don't try to be excellent, right? That I will not make any mistakes. So sometimes people think that when all the lights are green in the road, only then I will take my car out. It is never possible, right? Sometimes lights are red, sometimes are green. So we should have a growth mindset, right? So try to be better version of yourself in every day, not to run after the excellence. Then we have this. The first step towards knowing is to see that you do not know. The very beginning of real learning is to realize your own ignorance. If you believe you already know everything, your mind closes out. It's like if my cup is already full, nothing new can be poured, right? But if I see it is empty, I'm ready to fill it. So try to learn new things. Don't think that you know everything, right? There is always a room for new understanding, right? So when you see and admit you do not know, you open the door to curiosity, questioning, and new discovery, right? So you don't have to see the whole staircase, just take the first step. And one more thing, success need is always give your best performance in your every situation. So whether your salary is $1,000 or $10,000, whether you have one student or 100 students in your session, so whenever see your work, he must say that I have seen the better work. I have never seen the better work than this, right? So give your best, right? So there may be always better people than you. Don't try to compare with them, right? So try to give your best and leave the results to the God. So if you have no results, even then keep working. If you have bad results, even then keep on working, and great results, even then keep on working. This is the only way to success. And always invest in yourself, because highest ROI comes from investing in yourself. Be a lifelong learner by reading books, taking online courses, learning from mentors, experience new things, because the highest ROI comes from investing in yourself. Remember, my friends, if you try to achieve something, there is no guarantee you will get success. But I will give you one guarantee. If you do not try, you will never get success. So keep on trying with your full potential and complete honesty. and leave the results to the highest power. And one more thing, before jumping into topic, I request everyone to please mute your audio connection and please put your phones on the silent mode. Moreover, your involvement in the class is critical for your success, right? So I request you, if it is not absolute necessity, then please close all kind of social media like your Outlook, Facebook, Instagram, or YouTube, etc. Right? Because even a genius can't do two tasks at the same time, right? So are you with me? So please write yes in the chat box and then we can continue to our first module. Can you please write yes in the chat box? Okay, thank you. Okay. And Veklivi, can you hear me? I'm missing yes from your side. Can you please write yes in the chat box if you can hear me? Okay. Okay. Then let's jump to the first module. So to understand private networks, first of all, we have to understand 5G building blocks. Okay, let's understand what are the 5G building blocks. So in the 5G building blocks, we have to cover a few topics like, so first of all, we have to understand 5G motivation. Why we require 5G. Then we have to understand 5G key drivers and use case, 5G performance requirements, frame structure, spectrum, technology components, deployment options, network slicing, and the multi-access edge computing. So first topic will be 5G motivation. So let's set up the stage by talking about RAN first. Okay, so radio access network. So these are commonly known as cell sites as well, right? So these are the strategically placed to provide wireless coverage to user within a specific geographical area. You can see it all around, right? You can see it everywhere actually, right? RAN, radio access network. So they have various components like radio, antennas, BBUs, right? So the main purpose is to provide users reliable and the consistent coverage, right? So when you are planning the deployment of RAN, network operators consider various factors like they consider population density, they consider topography. These things are very important in case of planning and design, right? So we should understand it. Topography, then they understand like building density, then they have to talk about population density, right? So these things are very important in case of RF design and planning. In addition to that, they will talk about traffic patterns, right? So we have to take many factors to design and plan. For example, in high population density and building density and high traffic, network operators may need to deploy more cell sites. But in rural areas where population is very less, right? Network operators may need to deploy fewer sites with higher output power, right? So the placement of RAN affects the overall network performance. So to provide seamless coverage and mobility, we need to strategically place this access network equipment, right? So whenever you want to go from Virginia to California, so that you should have seamless coverage. You will not make a call drop. So in case of RAN, you know that it consists of three parts. One is radio, second one is antennas, and the third one is BBU, base band unit. So first one is BBU. So you know that if it is site, right? If it is site, then antenna may be on the top and radio may be on the top or on the base. So here may be the radio and then BBU is on the ground, right? So BBU is typically located here in the tower, right? So this is responsible for baseband signals and it is placed in the equipment room and connected to RRU through the optical cable, right? And it has various functions like it has performed like DSP, right? Digital signal processor. It provides like FEC, forward error correction. It provides modulation and demodulation, right? Then it is also responsible for channel estimation. Then it is also responsible for RRR, radio resource management. And then we have this radio. It is also various names, like some people call it RRU as well, right? RRH. So various names are there, right? And it has various functions, like it acts as a transceiver, right? Because it transmit and receive the user signals to the base station and the vice versa. And it provides different signals like VSWR, RET, right? It supports many things like this, right? And it provides back-to-back supports and connectivity to user like power, delay, etc. And then you have the CPRI cable. So CPRI cable is between, this is also called CPRI cable, right? CPRI. So the common, what the full form of this is the common public radio interface, right? So it enables the high-speed transmission of data over a fiber optical cable. It allows the RRU and the BBU connection. So this is the common public radio interface. Nowadays, it is not necessary that basement is near the tower. Basement can be at the centralized location as well. So the CPRI is an interface that sends data from RRU to the basement unit. It is a serial interface, which is very high speed connection. Basically, it is a way of translate all those radio signals back to the computing function. Only thing is that there are two things introduced nowadays. One is CPRI, second one is eCPRI. So in case of CPRI, it uses point to point fiber, right? It uses point to point fiber or radio signal, right? In case of eCPRI, it uses Ethernet based packet transport, right? This we should understand. Ethernet based packet transport. Okay. So since in 5G we require high level of speed, so this makes it make it suitable for 5G networks, right? So in 5G nowadays we are using eCPRI as compared to the CPRI. Yeah. Then you have this various telecommunication systems. So wireless telecom system components are composed of three main components or parts. So we have first of all user terminal. First of all, we have this user terminal, right? So these are the user terminals like for 3G, 4G, 5G. In 2G, it's also called the mobile station. So other examples can be smartphones, tablets, laptops, and other mobile devices that are equipped with the wireless connectivity features. So then the user terminals are connected to the radio access network, right? So there is an interface, air interface, and they are connected through the air interface to the RAN. So the RAN is responsible for providing the wireless connectivity required for the mobile devices. So the radio access network includes parts like antennas, radios, and the BBU, right? And these are connected through the air interface. So we are using a wireless connectivity. So we are using a different set of frequencies and we call it the radio frequency, right? So we use here radio frequency. The radio access network is also connected to the core, right? You can see radio access network is connected to the core network. So the core network is responsible for managing the overall operation of the network. It includes routing traffic between different networks. It also provides services such as voice calling, messaging, data services, right? So these are the different means to connect the core network and the radio access network. So these are connected through microwave, fiber optics, or the satellite as well. So if there is challenge in the terrain or long distances, then you are limited by the curvature of the earth. So in that case, you will use satellite to interconnect this. Okay. So these are the main components of a wireless telecom system. So you have the user terminals connected to the radio access network, and radio access network is connected to the core network with the help of this backhaul. And let's see the evolution of the mobile communication. So as you know that we have grown from 1G to 5G. So in case of 1G, which is the foundation of mobile technology, was introduced in 1980s. Then comes the GSM that was introduced in 1990s and it has mobile telephony for everyone. And after that 3G comes, which is UMTS. It is introduced around 2000 and it is the foundation of mobile broadband. After that, in 2010, around 4G comes and it enhances our mobile broadband. And then finally comes 5G, which is future mobile communication around 2020. And it has various new cases introduced like EMBB, URLLC, and the MMTC, right? So many cases are introduced. So it provides diverse opportunities with the help of this 5G. And we have different RAN names in different generations. For example, in case of 2G, it is also called GERAN, GSM Edge Radio Access Network. In case of 3G, it's called UTRAN, UMTS, Terrestrial Radio Access Network. In case of 4G, it is called EUTRAN, Evolved UMTS, Terrestrial Radio Access Network. And then in case of 5G, it is called NGRAN, Next Generation Radio Access Network. Some people call it new generation, but according to 3GPP, it is Next Generation Radio Access Network. And again, RAN has its own name for every generation of cellular mobile telecom, but all have the same working principle. So there is an alliance called NGMN, Next Generation Mobile Network Alliance. So this is the one of the most important group or alliance in telecom. It is an association of mobile operators and vendors, and it was founded in 2006. So what does NGMN say about 5G? So NGMN says that 5G is an end-to-end ecosystem. Interesting. They never talked about in solo. So they're always talking about end-to-end ecosystem, right? So this ecosystem is very interesting because we don't want simply shut down one technology because we are moving towards 5G. We don't want to shut down 4G. We don't want to shut down Wi-Fi. We always want to coexist as much as possible with other technologies, like I said, 4G, Wi-Fi, 3G, etc. Then we have this fully mobile and the connected society. So we are not going to talk anymore as a connected network. We're talking about connected societies. The word itself is very interesting. The moment you say society, which includes everything, the moment you say society, we talk about all the vertical and horizontal markets. We talk about medical applications, IoT applications, smart cities, smart grid, anything you can think. You can have a huge amount of list. You can see, then we have this quality of experience. So nowadays, we do not limit ourselves to the quality of service. We're talking about quality of experience. So there are two words. One is quality of service and one is quality of experience. While quality of service measures KPIs like reliability, retainability, etc. But quality of experience focus on actual individual user experience. So we are referring to quality of experience. It means basically the user experience. So what is the basic experience you could get with the 5G network, right? So finally, at the end of the day, we need money, right? So we need business because we need money, right? So this is the high level vision of NGMN on which whole 5G is based. So world as we know is changing. So the NGMN, which is Next Generation Mobile Networks, had described 25 potential use cases of 5G. But instead of 25 potential use cases, they have grouped into 8 use case families, right? So let's talk about those 8 use case families introduced by 5G or NGMN. So the first one is broadband access in the dense areas, right? So they want high data rate. They want lots of data so that people can watch, for example, high definition videos. They can share high definition photos or videos while watching a football match, while watching a soccer match, right? So network has to support ultra high connection density, high data rates, and low latency, right? So that they can enjoy everything everywhere, even where there is lots of people, lots of dense population, right? Then you have this broadband access everywhere. So since we are living in cities, so we don't face any problems. But now, even now, more than 40% people don't have access to the broadband. So the aim of 5G is that the data rate should be at least 50 Mbps everywhere, even near the cell edge, right? So as you know that while moving away from the cell, our coverage reduces, our RSRP reduces, our data throughput reduces, right? So the NGMN vision is that even at the edge, the data rate should be at least 50 Mbps. And the third case is extreme real-time communication. So in the 5G, we are talking about end-to-end delay of just 1 millisecond, right? So there are two things. One is called sensors and one is called actuators. So sensors works on various variables, like they can work on temperature, pressure, and moisture. And an actuator performs a task based on the sensor input. So suppose there is a fire in a forest, right? So sensor should sense that fire and immediately inform the actuator. An actuator will run a machine and then water can be started and it can be thrown on all the forest so that fire can be stopped as soon as possible. So the moment sensor sends something and the moment actuator get message from sensor, that time should be less than 1 millisecond. This is the aim of 5G, right? The fourth point is massive Internet of Things, smart variable and the sensors, right? So, for example, a traffic controller may control the operation of traffic light based on the feedback, right? We can have watch can control everything, our washing machine, our refrigerator, all the things it can control. So it has massive. Then you have drones with low power, high battery life, low cost, right? So this comes under massive Internet of Things. These are the first 4 points. And after that, we have high user mobility. In case of 5G, it can support speed of 500 kilometers per hour. In case of 3G, in case of 4G, the speed was just 350 kilometers per hour. So it means that even at 500 kilometers per hour, connection will not be lost, right? So it can provide satisfactory services at high speeds as well, like in bullet trains and maybe in the aeroplane as well in the future. And then you have this ultra reliable communication, which depends on the reliability and the latency, right? Suppose we are doing a remote surgery and there is a connection lost, or there may be latency of very high, right? There may be latency very high. In that case, a person can die, right? There can be some wrong procedure can be done on the person, right? So remote surgeries. Second example can be driverless cars, right? In case of driverless cars, if reliability is not proper, if latency is not less, this may cause to accident. So ultra reliable communication is dependent on the reliability and the latency. And then we have this broadcast like services, so that news can be broadcast. So if there is a flood anywhere, everyone should know immediately and they should leave the house. And then we have this life communication, public safety, and the emergency service. So these are the 8 use cases defined by NGMN. So latency of 5G is far less as compared to LTE. Also, reliability of 5G is far better than LTE. So we'll discuss the actual numbers in a bit, but a long story short, future will be dependent on low latency, high data rates, high mobility, reliability, and the connection density. And those numbers are not enough in LTE. That's why we need 5G. Then let's talk about industrial revolution as well. So in the 18th century, the steam engine was the primary technology. As opposed to wind power, the steam engine started powering ships, right? Then second industrial revolution is all about electricity. Internal combustion engines. In this case, internal combustion engines destroyed the steam engines market. The third industrial revolution started in around 1930s, and it's all about transistors and the wireless communication. If you know the company called Sony, right? So it was introduced at that time only, and you may know that it's from Japan, and it makes many things like cameras, TVs, radios, mobile phone, etc. And then comes the fourth industrial revolution, and it's dependent on the artificial intelligence and decision making capabilities in machines. So here, the main purpose is to develop human-like micro manipulation ability in the machines as well. So therefore, fourth industrial revolution will keep reducing human roles further. Consequently, due to this progress, many products and process will require no human rules for operation. So with the help of 5G, AI and IoT, certainly a huge transformation is occurring. But we should not be fearful of this AI. If you know that in 90s, right? In 90s, computers came, right? And we thought that all the jobs will be gone and we have to sit at home. No, the people who do not learn computers, yes, they have to sit at home. But people who learned computers at that time, who became software engineers, they are at good post, right? They don't have to worry about that. So yes, with the help of AI ML, the traditional jobs may gone away, right? But hundreds, millions or billions of new jobs will be created. Only thing is that you have to learn AI ML, right? So it is future technology, present technology, and you can't get rid of that, right? So as soon as possible, please start reading about AI ML. There are thousands of books, thousands of YouTube videos, thousands of materials available on Google. So start reading AI ML. It's very, very important. Okay. So 5G building blocks. So we have covered first part, which is 5G motivation, right? And then let's jump to the second part, which is 5G key drivers and the user cases, right? Let's talk about that. Before jumping to 5G key drivers and use cases, any questions, please let me know. Okay. So if you don't have any question, let's jump to the second part, which is 5G key drivers and the use cases. So we have discussed the motivation of 5G. So we have explored why we need 5G system, why 4G is not enough. So eventually we know that 5G will not be enough, but I think 5G will be at least there for next 5 years. This is my belief, but the way things are improving, we never know. 6G may come tomorrow. Right? Anyways, now we'll go through 5G key drivers and the use cases. What are the practical things that make 5G different from the previous technologies? The performance requirement mentioned in 3GPP documents are useless for a common person. His only requirement will be that how his life will be different by using 5G as compared to 4G. Why should he pay for 5G? So this chapter is all about 5G exciting use cases. I promise you some really exciting stuff I will be taking about in this, right? So in simple words, I want you to understand what can we do with the help of 5G technology. So let's get it going and let's get it amazed by the 5G technology. So there are wide use cases of 5G, for example, broadband and media everywhere, control of services and infrastructure, smart vehicles and transport, remote devices, sensor networks, and much more. And all these things are dependent on very high end user data rate, high traffic capacity, massive number of devices, very low device cost and device energy consumption, very low latency and ultra reliable connectivity and availability, right? So these things are dependent. So what are the uses cases of IMT for 2020 and beyond? So there is one more telecom body similar to NGM which defines some similar use cases. It is ITUR, which is International Telecommunication for the Radio Communication Center. Under it, it comes IMT, and IMT for 2020 means IMT 5G, right? So it has identified three uses scenarios. So these three scenarios represents the cases with an extreme 5G requirement target, right? So these are quite similar to NGMN. So let's talk about those three cases as well. So first case is EMBB, enhanced mobile broadband. It basically means more data to you as a consumer. So because if you took maybe few minutes to download a video few months back or few years back, but hello, in case of 5G, it takes few seconds to download a video. So it provides a strong technical case because every application is now data demanding. We need more and more data every day, right? So EMBB addresses the human-centric use cases for access to multimedia content. Demand for data is continuing to increase and it will never stop, right? It is increasing a lot every day. So the enhanced MBB user scenario will come with new application areas and requirements. In the end, it's all about seamless user experience. Examples can be 3D videos, ultra high definition screens, work and play in cloud, and the augment and the virtual reality. Then comes the second case, which is URLLC, ultra reliable and low latency communication. So it is the most exciting case, I think, but it's very difficult to achieve from the tech point of view. So no idea from where this term comes, URLLC, but its full form is ultra reliable low latency communication. Here the main aim is to remove the wire, right? So nowadays, if you have camera at home, then it is working through a wire, right? Home camera, right? If it is various machines are connected in a factory, they are connected through a wire, right? So here aim is to remove that wire so that we can connect each product wirelessly, right? So it has strict requirements related to throughput, latency, and the availability. So some examples may include like industrial manufacturing, like remote medical surgery. As I said earlier, if there is a reliability gap, latency gap between the doctor and the patient, then the surgery may go on wrong, right? There may be self-driving cars, there may be accidents if we don't have reliability and the latency concept, right? So we are really trying to disrupt the heavy industries, which normally would rely on the different technologies, right? We want to remove here wire. And last but not the least, then we have this IoT application. Here we refer to massive machine type communication. It is also called MMTC, right? So in this, we have lots of IoT devices. Then those devices should be low cost, low power, but high battery life, or you can say long battery life, at least of 10 years, right? So these use cases characterized by very large number of connected devices. They typically transmits a relatively low volume of non-delay sensitive data. So devices required to be low cost, have a very long battery life. So these are the 5G technical use cases. Think of it like a pyramid, right? So you have all three use cases: EMBB, URLLC, and the MMTC. Then you have this heterogeneous use cases, diverse requirements. So as we reviewed earlier, 5G can be broadly divided into three parts. One is EMBB, URLLC, and MMTC. So there must be some minimum requirements to fulfill these cases. So in this slide, we have seen what are the minimum requirements, right? So first one is MMTC, right, which is massive machine type communication. It connects billions of sensors and machines. What are the requirements? It should have large number of devices. How many number of devices? 1 million devices per square kilometer, right? Then it should have deep penetration, right? It should even go to the forest where it's very difficult to reach, even in the deep water, right? And it should be power efficient. Then you have this M, after MMTC, we have this URLLC. So here requirements are the low latency, high reliability, vehicle to everything, right? So if you don't have reliability, there may be accidents, right? So it should have these things covered. And after that, we have this EMBB, which has high rates, enhanced mobile broadband, and this tactile web. So what is this tactile web, guys? Anyone? So basically, tactile web refers to the integration of haptic, or you can say touch-based feedback, right? It allows users to feel web content through devices that simulate touch. So it's very emerging concept in human computer interaction, and it aims to make digital experience more immersed and accessible. For example, before buying a cloth, right? You can touch it, you can feel it. This is the concept of the tactile web, right? And then we have this high definition video call, and then you have this FTTX, fiber to the everything, right? Right now we have fiber. If we need connection between backhaul and RAN, if we need connection between core and RAN, there is a fiber. So 5G wants that there should be some alternative to FTTX, so that there should not be any wires, right? So this can be possible. So the main purpose to introduce 5G is extreme broadband, low latency communication, and the massive networking for the Internet of Things, which will transfer our life. So these are the three use cases introduced by 5G, right? Like enhanced mobile broadband, URLLC, and the massive machine type communication. Again, what are the 5G use cases? First one is MMTC, second one is EMBB, and the third one is URLLC. So these are the three use cases introduced by 5G: MMTC, EMBB, and the URLLC. Then we have this consumer centric to the business centric. So let's look how mobile networks have evolved from being all about the consumer to the new powering business. So we started with 1G, which gives us the voice call, and then comes the 2G, which introduced text messaging, and then 3G brought us the mobile internet, and the 4G give us the fast video streaming. But the 5G is a game changer. It is not just for faster browsing, it is built for smart cities, autonomous cars, remote healthcare, and the advanced industries. So we are moving from just connecting people to connecting everything, people and business. That is the power of 5G, right? And before jumping to the next session, let's have some quiz. So first question is, what are the three uses cases scenario of IMT 2020 and beyond defined by ITUR? So the first option is enhanced mobile brand, massive machine type communication, and broadband multicast services. Second option is EMBB, MMTC, vehicle to vehicle, and V2X. And this is the third option, and this is the fourth option. Please let me know the correct answer in the chat box. I think I have muted for a long time. So I'm not sure from which slide I have muted. So can you tell me from which slide I was muted? I forget which one, which slide? This one? Have you seen this slide? So after quiz, it was muted, right? Am I right, Shalin? Can you please tell me after quiz, I was muted, right? Okay, thank you. So I think I was muted. So let me explain this again. In case of, as I discussed, 5G has introduced three use cases. One is EMBB, which is enhanced mobile broadband. Then you have URLLC, and then we have MMTC. Each use case has different requirements. So as I said earlier, there may be many cases in the market, but 5G defined it under three these use cases. One is EMBB, URLLC, and one is MMTC. For example, EMAB has given high importance to the capacity and the peak data rates. This URLLC has given more importance to low latency and the reliability. And this MMTC gave more importance to high connection density, low data rates, and the long battery life. So you can see that there are many use cases here. So the first case, EMBB has requirements of gigabytes in second, right? So for example, this 3D videos and ultra high definition requires high data rate, right? This work and play in cloud may be require medium data rates, right? So as you move from here to here, there may be less requirements related to data, but high requirements related to reliability or low latency. As you move from here to here, there may be low requirements for reliability, but high requirements for connection density. As we move from here to here, there may be high requirements for the data rate, right? And low requirement for the connection density. So it's all about these three cases. So all the cases which are available in the world can be merged into these three high level cases, which is EMBB, URLLC, and the massive machine type communication. And thanks, Shalin, for letting me know that I was muted. Thanks a lot. So we have discussed these three 5G uses scenario, right? Let's talk about next 5G building blocks. So here we have 5G motivation, we have 5G key drivers and use cases. The third one is 5G performance requirement. So third learning objective here is the 5G performance requirements. Let's talk about 5G performance requirement. So 5G performance requirement. So I always say that 5G is both boring as well as very exciting. It's boring because it follows the same trends we have observed over the last years as we move from 1G to 2G, 2G to 3G, and 3G to 4G. Things always improve by an order of magnitude, data are always multiplied by 10 or 100, number of devices increased, etc. So this thing is same as previous technologies. But what is new or exciting about 5G? So now the exciting thing about 5G is that for the first time, it is so good that it can support a lot of industry process. We have just gone through many use cases which were never there before in any of the technologies. Because of these new use cases, 5G is very exciting. So as these cases were not available in the previous technologies, 5G is a game changer. Take example of latency. In 5G, latency is very low. That's why we can have remote surgeries, vehicle to vehicle communication, vehicle to everything communication. Hey, it's so low, I can replace my physical cable, my Ethernet with a wireless system now. And this is one of the most exciting development in case of 5G. And before jumping to the performance requirement, we should compare 4G versus 5G as it will give us the better understanding of 5G. So when we compare 4G, LTE and 5G, first of all, there are some similarities as well. So first box here you see is the OFDMA. In 5G, we do not define a new radio access technology. So we are still using OFDMA, orthogonal frequency division multiple access. And this is what we are using in LTE as well. So now we are using that in 5G and 4G both. So now in 5G, it may be different in terms of features, in terms of flexibility, but the name is same, OFDMA. Only difference is that in case of 4G for uplink, we have to use SCFDMA. But in case of 5G, you are flexible. In uplink, you can use single carrier FDMA or you can use OFDMA as well, right? So this is the concept introduced in 5G. Second thing is the spectrum band. So both of them can use multiple spectrum bands like PCS, AWS, 850, etc. Yes, in 5G, we have many new bands introduced like sub 6 gigahertz, millimeter wave, but 4G and 5G both have many spectrum bands. And the last box here is the core network. You may have heard of term called NSA, NSA, non-standalone. So in the initial cases of 5G, we are using the core of 4G. So that is also very similar between LTE and the 5G. So these are the few similarities between 4G and 5G. In addition to similarities, there are many differences as well. Let's talk about the differences as well. So first difference is RF channel size. In case of 4G, the maximum size is 20 megahertz. But in case of 5G, the maximum size is 400 megahertz. That's a huge difference, my friend. It's like 20 times more as compared to 4G. According to Shannon laws, capacity is equal to bandwidth log 1 plus sin R, right? So if we are able to improve this bandwidth, then capacity will be automatically improved. So in case of 5G, theoretically level, you can say that capacity is around 20 times more as compared to LTE. Second one is related to latency. In case of 4G, latency is tens of milliseconds, but 5G offers latency in single digit millisecond range. So we are trying to achieve 1 millisecond. That's the objective. I don't believe that will be met immediately, but that is the objective as we move on. Many applications, as I said, like remote surgery, driverless cars, are dependent on low latency. So it's very, very important that latency should be as low as possible. The third one is core flexibility. The 4G core is clearly less flexible. It is very monolithic. For example, if you have MME box, so that box will work as a MME only, right? If you have SGW box, that machine will work as a SGW. Then you have PGW. All these three things are monolithic. So if you assign one function to one box or one machine, then that will work as a that function only. MME box will work as MME, SGW will work as SGW, PGW will work as a PGW. But the 5G core is very flexible. It uses service-based architecture. So according to need, that boxes can be changed. For example, there are many things introduced like AMF, AUSF. So according to need, one box can work as a AMF as well as AUSF, UPF, etc. Right? And it used many new techniques are introduced like network slicing, NFV, SDN, right? Cloud computing, MSE, multi-access edge computing. It allows for user plane and control plane separation, right? Earlier, if you have to upgrade user plane, you have to upgrade the control plane as well. So now it's not a requirement. So if you want to upgrade user plane, you can upgrade only the user plane. If you want to upgrade control plane, you can upgrade only the control plane. So 5G will allow for the unique ways to deploy applications. I hope that makes sense, right? Then we have talked about the 5G capabilities. And before jumping to 5G capabilities, we should have some idea about the 5G standard bodies as well. So first one is IMT, which is International Mobile Telecom 2020, right? So it is also called as 5G. And then we have ITUR, which is International Telecom Union for Radio Communication Sector. The main job of ITU is to set a benchmark for all future communication. The result is IMT 2020, which is 5G in simple terms. For high level, you can say that IMT 2020 follows the same structure as in previous Gs. For example, in 3G, it is called IMT 2000. In case of 4G, it is called IMT Advanced. In case of 5G, it is called IMT 2020. So let's jump into the 5G capabilities. So according to ITU, 5G is expected to provide user experience matching the fixed networks, right? The wired networks. The enhancement will be realized by various factors like increased data rate, enhanced spectral efficiency, and the reduced latency. So let's talk about what are the 8 cases introduced by 5G. So these are the 8 cases introduced by 5G. So in this spider chart, the key capabilities of IMT 2020 is shown. So here we have IMT 2020, which is 5G, and this IMT Advanced, as I told, this is LTE, right? Let's talk about those things. The first capability you see here is the peak data rate. You can see that in case of 5G, it is 20 GB, but in case of LTE, it was 1 Gbps. So in case of 5G, the maximum achievable data rate under idle conditions, when all the bandwidth signal is very high, is provided to one user, then it should be at least 20 Gbps. In case of LTE, it was just 1 Gbps. Second one is user experience data rate. That is achievable data rate that is available everywhere. So it is based on the environment. Like in urban and suburban areas, a user experience data rate is 100 Mbps per second. But in case of rural, it can be 50 Mbps, right? But in case of LTE, it was just 10 Mbps. Then we have this spectrum efficiency. So spectrum efficiency is 3 times more as compared to LTE. In case of 5G, it is around 30 bps per hertz. In case of LTE, it was 15 bps per hertz, right? So what is spectral efficiency? Just to let you know, spectral efficiency is equal to throughput divided by bandwidth. So higher the bandwidth, higher the throughput. For example, if you have bandwidth of 2 megahertz and it supports a data rate of 15 Mbps, 15 divided by 2 is equal to, the spectral efficiency is 7.5 bits per second per hertz, right? This way you can measure the spectrum efficiency. In some interviews, I have seen people ask, do you know the formula for spectrum efficiency, how it is calculated? If my bandwidth is 40 megahertz and my raw data is 30 Mbps, then what's my spectrum efficiency? So you should know the formula. Spectrum efficiency is throughput divided by bandwidth. And then comes the mobility. So mobility means the maximum user speed at which a defined quality of service can be achieved. Or you can say the maximum speed at which 5G is feasible. So IMT 2020 is expected to enable speed of 500 kilometers per hour. In case of 4G, you can see it was just 350 kilometers per hour. Then you have latency. So 5G will be able to provide less than 1 millisecond over the air latency, which is far less as compared to LTE. Then you have this connection density. So the total number of connected or accessible devices per unit area. And the fourth one is, and the seventh one is network energy efficiency. The capability to minimize the RAN energy consumption. Also providing a better area traffic capacity. And the eighth one is area traffic capacity. So this is the total throughput served per geographical area, right? So now we have seen the 8 capabilities of 5G. So these 8 capabilities should be there if you want to call any system as 5G. Therefore, the performance target of 5G should be much higher as compared to LTE, right? Only then a system is called 5G. And these are the 8 currencies as defined by Verizon. So if you go to this link, you can open this 8 currencies. And what are the 3GPP defined requirements for 5G? Let's talk about those things as well. So main 3GPP requirements for NR are defined in TR 38.913. So you should know about the 3GPP documents as well. And it is in the technical specification 22.261. So if you go to 3GPP website and you put this number, so this data will come. So data rate should be 20 Gbps. In the downlink and uplink, it should be 10 Gbps. After that, we have peak spectral efficiency. So in downlink, it should be 30 Bps per hertz, and in uplink, it should be 15 Bps per hertz. And reliability is all about 5 nines, 99.999%. Then we have connection density, which should be 1 million devices per square kilometer. Then we have this mobility. It can support 500 kilometers per hour. So if someone is moving more than 500 kilometers per hour, then call will be dropped, right? They can't take the advantage of 5G service. Then you have latency. So latency is 0.5 millisecond for uplink and downlink for URLLC. But for EMBB, it is 4 milliseconds for uplink and 4 milliseconds for downlink. You should remember, in case of URLLC, it is 0.5 ms. In case of EMBB, it is 4 milliseconds. These are the 3GBP defined requirements, right? There is one point here is coverage, which is 164 dB. So coverage means like in case of, so if you define technically the reach, the coverage, the penetration, or the coverage in one word, then you should know the MCL, maximum coupling loss, or you can say MPL, maximum path loss. So maximum coupling loss or path loss is the maximum channel loss between the user equipment and the G node B at which data services can be delivered. Practically, it includes antenna gains, path loss, shadowing, and other impairments and the losses and the gains. We'll talk about in details in the link budget as well. But you should know that in the CAT M1, or you can say LTE-M, it was around 155 dB. But in case of 5G, it is 164 dB. So you can see an extraordinary difference of more than 8 dB. So this indicates significant advantage of 5G over LTE. So think buildings, remotes, and how to reach location, right? So think buildings, remotes, and hard to reach locations, and even underground to extend, right? So LTM is suitable for indoor coverage, but 5G is better. I'm talking here about the MMTC devices, right? In that case, 5G is far better as compared to LTE. So we are talking about reliability. So as I said earlier, in case of 5G, reliability is 99.9%, right? So what are the advantages of this high reliability? You can see the downtime per year is 5.26 minutes. So if reliability is 4 nines, then you can see that downtime increases 10 times. So in case of LTE, our downtime per year may be 52.60 minutes. But in case of 5G, it's reduced to 5.26 minutes. Downtime per month is reduced to this amount. Downtime per week is, so downtime per day is just 864 millisecond in case of 5G. But in case of 4G, it can be 8.64 second. Again, availability is the measure of percentage of time the equipment is operable, right? While reliability is a measure of how long the item performs its intended function. Generally speaking, a reliable machine has high availability, but an available machine may or not be a very high reliability. Again, we have discussed the 5G performance requirement. So peak data rate is downlink 20 Gbps and uplink 10 Gbps. Latency is less than 1 millisecond. In case of EMBB, it is 4 millisecond in uplink as well as downlink. Then number of devices connected are 1 million devices per square kilometer, and then cell as data rate is 100 Mbps. So these are the performance requirements of the 5G. And again, we have discussed the 5G target capabilities as well. So let's talk about some questions and then we'll jump to the next part. So what are the 5G requirements for the data rates? Can you please give the answer in the chat box? Yes. So right answer is B, which is 20 Gbps. What about the user plane latency in case of EMBB? Yes. So right answer is D. What about peak spectral efficiency in 5G? Yes. Right answer is A, which is 30 and 15. Maximum mobility is 500 kilometers per hour. So we have discussed these targets in case of 5G. Let's recall what you have learned. So first of all, we have learned there are various 5G building blocks. So in this training, we were able to cover 3 5G building blocks. One is 5G motivation, 5G key drivers and use cases, and the 5G performance requirements. In next class, we may cover the rest of these topics. Again, 5G is not just a 4G plus 1. There are many new things introduced in 5G, like millimeter waves, cloud computing, network slicing, NFV, SDN, service-based architecture, NSA, SA mode, standalone, non-standalone, all these things were introduced in case of 5G. Flexible frame structure, all these things were there, right? And as we have discussed, NGMN Alliance defines 5G requirements for use cases, right? So what are the agenda? So this is 5G end-to-end ecosystem. And we have talked about all the 8 cases related to connection density, traffic density, efficiency, business model, all these things we have discussed. After that, we have discussed the 8 cases defined by NGMN related to higher user mobilities, reliabilities, broadcast services, and the lifeline communication. All these things we have introduced. After that, we have talked about timeline, like 1G was introduced in 80s, then 2G comes in 1990s, then 3G comes in 2000, after that 4G comes in 2010, and now It's the era of 5G. So 5G is introduced in 2020. Then we have talked about consumer-centric to business-centric model as well, right? We have talked about how the things moved from 1G to 5G. In addition to that, there was a 3G, 5G roadmap also we have discussed. And these are the 5 important performance targets that should be there to call any system as a 5G system. So peak data rate should be 20 Gbps, uplink data rate should be 10 Gbps, and all these things we have discussed in this session. And we have discussed about the 5G performance requirements according to user performance perspective and the system management perspective as well. In the summary, we have discussed 5G user scenario includes EMBB, MMTC, and the URLLC. And the 5G aims for 20 Gbps peak data rate and 10 Gbps in the uplink, 1 ms RAN latency, 10 Mbps per square meter, and 1 million IoT devices per square kilometer. Okay, friends. So this is all from my side. Thank you again for joining this training and for giving me your valuable time. I truly appreciate your commitment to learning and growing. Take care of yourselves, your families, and always keep pushing forward. Keep learning, keep growing, and continue striving for success.